Last section for chapter 13 looks at catalysis, so talking about a catalyst. Catalyst we've kind of talked about on Tuesday, but catalyst is something that's going to be present in the reaction both in the start and in the end. And the purpose of a catalyst is to increase our rate of our reaction by lowering the energy of activation. So it actually provides a different pathway for the reaction to take. And if we lower our energy of activation, then we have more molecules that can overcome that energy of activation barrier. The important thing about a catalyst, though, is that it's not consumed by the reaction, so it could change form in the middle of the reaction, but then it's regenerated in the end. And remember, that was different than the intermediate, which was formed in the reaction and then consumed. So it was produced and consumed. The catalyst is going to start, it could be used, and then it's going to end up the same way that it started out. So the catalyst still doesn't appear in the overall reaction. So graphically, if we look at our time on the x-axis, energy on the y, and we had our simple one-step reaction here, right, where our energy of activation was how much energy we had to add to get over that hill. And when we add in a catalyst, it's going to provide a different pathway that has a lower energy of activation. Okay, so this is our energy of activation of a catalyzed reaction. And by lowering that energy of activation, that hill that we have to get over, we have more molecules that will then be able to make that, so our reaction then should go faster because we have lowered the energy that's required. Some other vocabulary associated with catalysts is we can have a heterogeneous catalyst, which, as expected, heterogeneous we know to be different. In case of catalysts, we're looking at different phases. So if the reaction occurs in, say, the gas phase, our catalyst is in the solid phase, we'd call that a heterogeneous reaction. Homogeneous, we'd have everything in the same phase. For you biologists, enzymes, these are basically biological catalysts. Sometimes chemists, biologists probably too, refer to these. We have lock and key concept, okay, and that's where these enzymes are kind of shape specific, so not always necessarily just the elements that make up the enzyme, but the shape that that enzyme has. So if, for example, our molecule that we want to break apart kind of has this shape here, our enzyme needs to be a shape that fits that molecule. So we could have, say, something like this. This would be our enzyme. Our catalyst, our enzyme, then does some sort of bonding with our substrate there, our molecule, our other one. And chemistry happens, our reaction occurs, and let's say we were trying to, I don't know, break this apart into two pieces. And then the important piece to a catalyst is that we regenerate our catalyst in the end so that it can continue on in our reaction and react with other substrates.